Hello everybody. Today we'll discuss about analog and digital signals. As we have been discussing about the basics of signal, different types of signals, different operations on signals, classification of signals. So moving ahead, this lecture will introduce analog and digital signals. To begin with, let's understand again what is signal. We know that signal is an entity or a function that always conveys some meaningful information about a phenomenon or an event. For example, speech signal, EEG signal, like we can see here, EEG signal, beta, alpha, theta, delta, gamma. These are the different brain waves which carry some useful information about the brain. We can determine the status of brain, whether it's in sleep state, whether it is active, whether it is in critical thinking mode, depending on different wave patterns of alpha, beta, theta, gamma, and delta. So these waves or signals carry some useful information about the brain. So this is a general definition of signal. Now let's understand what is analog and digital signal. So analog signals are continuous signals that change with time period, whereas digital is a signal that is discrete in nature. So we can see in the diagram 1 that the signal is continuous in nature, whereas the second signal is discrete in nature. So discrete means is in the form of pulses or samples. So let's watch two important videos in order to understand analog and digital signal. The first one is
Analog and digital signals. There are two different ways of sending information, either by analog or by digital signals. So what's the difference? Well, let's look at the analog signal on screen.
So let's begin with from the beginning. That discusses about analog and digital signals.
Analog and digital signals. There are two different ways of sending information, either by analog or by digital signals. So what's the difference? Well, let's look at the analog signal on screen. We can see that it varies continuously in both amplitude and frequency, and the signal can take one of many different values. Now let's look at a digital signal. So here we see that the signal can only take two values, either a 1 or a 0, which we sometimes call on or off. Digital signals are sent as a series of pulses of either 1s or 0s.
Digital signal is expressed as the stream of bits, is being called as pulses. Sometimes we call it as on state and off state. Like see here, the lower pulse means off state. This is on state. So digital signal is expressed as stream of.
Okay, so that's great, but which is better? Well, digital is a much better way of sending information over long distances. Now let's see why.
For long distance communication, digital signal is preferred over analog.
So here is someone talking on a phone. The signal from their voice is analog sound, and it enters the phone and is converted to a digital signal and then sent out via microwaves to a phone mast, which then sends it on to a satellite and then back down to another phone mast and then on to the person receiving the phone call. Let's look at the signal received by that phone. If we look we can see it has picked up a lot of noise or interference, but it's still really obvious exactly what it should look like, so the phone can easily convert it back perfectly to be the same as the original signal. Now let's look at this using analog. So now the analog signal, the sound, enters the phone and is turned into an analog electrical signal and sent down copper wires. Now, note how it picks up noise and interference, and the amplitude is reduced as it travels.
Which means that the analog signal is more prone to noise, whereas digital signal is immune to noise. So a lot of noise can be added in analog signal. Therefore, if you transmit analog signal for long distance, at the receiving end, the signal will be much noisy and we will not be able to reproduce. And therefore, digital signal can be transmitted for a long distance.
Until it gets to the other phone. Now let's look at it again. It looks very, very different to the original signal now. It's almost completely impossible to know what this signal should have looked like. And it needs amplifying as well. This amplification is only going to amplify the noise just as much as it does the signal. So noise or interference has really damaged the analog signal. And this is why digital is so much better than analog. Noise or interference is just not a problem for digital, but is a huge one for analog, making digital signals much higher quality. Other benefits of digital are that it can carry much more information. In fact, you can send multiple different signals all at the same time. And
the
digital signals
point which is there or advantage which is associated with digital signal is, first one is better quality. Second one is it can carry large amount of information. So when we communicate something in terms of analog, the amount of information that can be communicated, that can be conveyed is lesser than what we can communicate using
also
digital.
Easily interpreted by computers.
We also know that computers are digital devices, and this is the age where at every stage of communication, computers or computing devices are used. So in order to interpret and understand the signal and the nature of the signal, quality of the signal, digital signals are better signals because it can be easily interpreted.
Computers.
So here we'll stop and we'll continue for the next one.
The electromagnetic spectrum. Light is actually an electromagnetic wave and is part of a whole spectrum of waves called the electromagnetic spectrum. The waves all have certain things in common. They all travel at the speed of light in a vacuum.
So let's go to our second video and then here it is. Yes. Let's watch another video and understand.
My job is to make college easier because students have a lot on their plates.
So let's watch this video and understand something more about analog and digital signal. So the credit goes to the Sunny Classroom and we're watching this video and understanding analog and digital signal again.
Hello, and this is Sunny. Welcome back. Today my topic is the difference between analog signal and a digital signal. We live in an analog world. Colors we see, heat we feel, sounds we make and hear are all in the form of analog signals.
I've already told you, all natural signals are, all signals which we see in the physical world are analog signal. That's what he's talking about.
All analog signals carry energy. If we use voltage to represent energy, analog signal wave should be smooth and continuous over time. By smooth and continuous, it means that within any range of analog signal wave, like from point A to B, there are infinite values in terms of voltage. A digital signal wave, on the other hand, looks like this if we draw the graph of voltage over time. Viewed from afar, the digital signal wave may look smooth and continuous, but when we look closely, there are tiny discrete
It's actually not
steps.
discontinuous. It may look from a far place that it's a continuous, but it's not actually continuous signal. It's a discrete.
By
line.
discrete, it means for any range of a digital signal wave, like from point A to point B, there may be very large but not infinite number of values. Each value in voltage can be encoded in digital number.
Whereas in analog signal, we have seen that each number can have any value till infinite. Whereas in the digital signal, each value in the voltage can be encoded either in digital
zeros or ones.
ones.
In a simplified view, digital signals are normally represented this way because in digital signal transmission,
Here, wherever higher
all
pulse
these
is there, it is represented by 1, and wherever there are low pulses, they are expressed by 0, 0, 0. Again, there are two consecutive pulses, higher pulses, so we are representing by 1, 1. For lower pulse, again, it is expressed or represented by 0. So it's a stream of ones and zeros.
values are in a form of zeros and ones. And we will talk about how to convert analog signals into digital data in a separate lesson. In summary, an analog signal can take any value within a given range of time. A digital signal can only represent one of the discrete set of values. As analog signals travel, they will become weaker and weaker. To make things worse, all kinds of interferences would create noises. To boost the fading analog signals, we need a device called an amplifier to increase their voltage. Analog signals are
The transmission, we can use analog amplifiers, a number of analog amplifiers in order to enhance the amplitude level, the signal strength, because we have seen that for long distance communication or for long distance transmission, the signal quality degrades. So in order to improve the signal quality, in order to boost up the signal amplitude and magnitude, a number of stages of analog amplifier
amplified, but at the same time, it also increases noises. Besides, the amplifier itself also adds some noises.
The problem with the analog signal transmission is we are boosting the magnitude of signal, but as we know that signal is also being corrupted over the channel, over the media where the signal is transmitted. So that corruption, that noise which is affecting the signal will also get amplified by the amplifier. So the desired signal as well as the noise content, both will be amplified, and ultimately the actual signal will be degraded much by the amplified noise signal. So that is the drawback.
Digital signals would also lose power over a distance. A different device known as digital regenerator is used to boost weakening digital signals. Digital regenerator, also known as digital repeater, takes the entire digital signals and reconstructs them to their original
In a similar manner, in place of analog amplifier and digital transmission, we can use repeaters. They are digital regenerators that actually boost up the digital signal strength, and therefore it is not affected by the noise.
At the same time, most noises will be eliminated.
You see here the comparison.
I hope this video is helpful. Thank you very much. And
Thanks, Sunny, for this video. Now let's resume our lecture again. Yes. So after watching the two small videos, we can see analog signal that is defined by using amplitude, time period, or frequency or phase. Digital signals carry the data and these signals are discrete. The digital signal carries the data in the form of binary because it signifies in the bits. These signals can be decomposed into sine waves, which are termed as harmonics. Every digital signal has amplitude, frequency, and phase like analog signal as well. And most of the image sensors are in the analog signal and digital processing cannot be applied on it. Therefore, it requires infinite memory. So analog signals are converted into digital by sampling and quantization process. You see here, we first of all convert the signal into the form of samples by using the sampling, where we convert the signal as a discrete time signal and it is quantized and certain encoding scheme is applied, and we finally convert signal into the digital form in the form of zeros and ones. The quantization actually, when we sample the signal, when we apply the sampling process, you see there are a number of samples, but it is very difficult to encode all the samples, the equivalent code or equivalent binary code. So some approximation is needed, and that approximation is done by the quantization process. And that quantized signal is encoded by the encoding scheme called also called as pulse code modulation, PCM, and the signal becomes digital signal. This is a table which highlights the difference between analog and digital signal. Analog signal, as we have seen, continuous and time varying. Digital signal is discrete and binary form. It is not time varying, but it is always binary form. Digital signals will be always in the form of zeros and ones. When we want to troubleshoot, there is a problem suddenly in the analog communication. It's very difficult, but troubleshooting is very easy in digital signal transmission. Analog signal is usually in the form of sine wave, and digital signal is in the form of square wave. Square wave means it represents pulses, high and low pulses, respectively for ones and zeros. The analog signal is easily affected by noise, prone to noise, whereas digital signals are stable and very less prone, or rather immune to noise signals. Analog signal continuous values to represent the data, and it uses discrete values to represent the data in digital signal. The accuracy of analog signal is affected by noise, whereas accuracy is not affected because we know that it is immune to the noise. It may be affected by or during data transmission, whereas for even long distance data transmission, digital signal is not affected. It uses more power, whereas digital signal requires less power. Examples of analog signals include temperature, pressure, flow measurement, etc. The examples of digital signal like DVD, computer, digital watches, and there are components in digital signal production and the system, capacitors, inductors, diodes are used in analog circuits, whereas transistors, logic gates, microcontrollers are used in digital circuits. If we talk about characteristics of analog and digital signal, there are a number of characteristics by which we can characterize, we can identify, we can qualify, determine the quality and the nature of signal, and that include adaptability, continuity, representation, data type, signal type, and so on. So let's begin with adaptability. Adaptability is analog signals are less adjustable for a range of use, whereas digital signals are more adjustable for a range of use. So it is adaptive for a large range of values for digital, whereas in analog case, the adaptability is poor. Continuity, analog signals use continuous variety of amplitude values, whereas digital signal takes a limited set of distinct values at consistently spaced spots in the time, that is discrete intervals of time. Type of data, analog signals are continuous in nature, whereas digital signals are always discrete. Type of waves, analog signal wave is typically sinusoidal, whereas digitals are generally in the form of square. Analog signal value type is positive as well as negative, whereas digital signal is generally positive. Security, the security of analog signal is not encrypted, whereas digital signal can easily be encrypted by using a number of encryption algorithms. Bandwidth, analog signal bandwidth is low, whereas the bandwidth required for digital signal is high. Hardware, analog signal hardware is not elastic and flexible, where digital signal, hardware requirement are required, and digital signal circuits are flexible and elastic. Data storage of analog signal is in the wave signal form, whereas digital signal stores the data in the form of binary. Portability, analog signals are portable, similar to thermometer, and low cost, whereas digital signals are portable, similar to computers and expensive. Data transmission in analog, it can be deterioration due to noise throughout the transmission, whereas digital signal is immune to noise, therefore deterioration is very less. Impedance of analog signal is low, whereas the digital signal impedance is high. Power consumption, analog devices use more power, whereas digital devices use less power. Transmission rate in the analog signal is slow, whereas transmission is faster in case of digital signal. Let's talk about advantages of digital signal, advantages and disadvantages. Digital signals are more secure and they do not get damaged by noise. Digital signals use low bandwidth. Digital signals allow signals transmitted over a long distance. It has higher transmission rate. By using digital signals, we can translate the messages in the form of audio, video into device language. Digital signals enable the transmission of multi-directional concurrently. There are advantages of analog: easier in processing, best fitted to audio transmission, passes higher density, and uses less bandwidth than the digital signal. Disadvantages of digital signal: sampling may cause loss of information. In case of digital, if sampling is not done properly, poor sampling is there, aliasing and other effects may cause loss of information in digital signal transmission. ADC and DAC are extra requirement for the digital signal transmission, and the digital signals develop quantization and round off errors also. Even though we don't have much noise in the digital signal transmission, but quantization and other round off errors are always there. Systems and processing are more complex in digital signals as compared to analog signal. Finally, disadvantages of analog signal. Analog signals are prone to generation loss. Analog signals are subjected to noise and distortion as opposed to digital signals. Analog signals are of low quality than digital signals. So this is how we come to the end of this lecture, and we have discussed about analog and digital signal in this particular lecture, where we have defined analog and digital signal. We have tried to understand the representation of analog and digital signal, and we have also explained how analog signal is converted into digital signal. Then finally, we have discussed advantages and disadvantages of analog signal. So when we conclude in a few sentences, all natural signals are analog signals, but in modern age where a lot of systems are digital systems, digital processing is involved, we need digital signal. So the analog signal needs to be converted into digital signal. For that, we use sampling that converts analog into discrete. Then we subject it to quantization and encoding process. And finally, we get our continuous signal in the form of stream of bits as sequence of ones and zeros. And the signal becomes in the form of digital signal. There are advantages and disadvantages associated both with analog and digital signal. But of course, in digital signal transmission, the transmission is fast. Of course, the bandwidth requirement is high. It's more than that, more than what is required in analog transmission. But the signal quality is very, very good as compared to analog transmission. But the bandwidth requirement is more in digital signal transmission. So major advantages are signal transmission is faster and the signal quality is extremely good in comparison with analog signal transmission. So that's all for this lecture. Thank you.